Welcome back, guys. It's time for another chapter. And as you can see here, this chapter is called vSAN Storage Space Efficiency. So what exactly are we going to be talking about in this chapter? If you've been working with vSphere and in particular vSAN for a while, you probably know that over the years, we have added more and more features that could potentially save you space. So when you look at this page, and this page they're telling you that as your environment grows and you continue to build more and more VMs, you may want to consider utilizing some of these space efficiency features. So what exactly we're talking about? If you think back, if you've been working with vSAN for a while, you may remember that in vSAN 6.2, which was vSphere 6.0 Update 2, back then we added a few of these features. In vSAN 6.2, we added, number one, RAID 5 and RAID 6. So those two techniques can save you a lot of space compared to using, for example, a two-way mirror or a three-way mirror. Be aware, RAID 5 and RAID 6 can only be used if you have the all-flash architecture. Not only that, in 6.2 we also added deduplication and compression. And dedupe, when combined with compression, can save you a lot of space. Having said that, in this version, in 7.0 Update 1, we've added the ability to enable compression only. So we're going to talk about why you have that and what is the advantage potentially of using compression only compared to dedupe and compression. Lastly, a few versions back, we introduced trim and map. Trim and map was introduced in 6.7 Update 1. And again, trim and map still in 7.0 Update 1 has to be enabled using the RVC, the Ruby vSphere console. So I'm going to show you how to do this. And not only that, I'm going to do a demo on how to use the RVC. In order, again, to enable trim and map, you need to know how to connect to RVC and be able to run commands. So I'm going to do a demo, a full demo on the Ruby vSphere console. Now let's take a look at the goals here. As mentioned, in this particular chapter, number one, we're going to describe all of these features that I just mentioned a second ago. Then we're going to dissect them. First, we're going to start with dedupe and compression. Once again, remember, this can only be enabled if you have the all-flash architecture, just like RAID 5 and RAID 6. After that, we'll talk about why we introduced compression only, advantages of disadvantages of one versus the other one. Then we're going to use and talk about RAID 5 and RAID 6. Please remember that in this lab, you already have a RAID 5 VM. Not only that, you may want to remember RAID 5 requires 4 hosts minimum and RAID 6 requires 6 minimum. So although I could create a policy for RAID 6, right now I would not be able to use RAID 6. And lastly, I mentioned before, I'm going to show you how to enable trim and map. So let's take a look at this page. Here, once again, we mentioned that over the years, VMware has added more and more features that potentially can save the customer a lot of space. Let's take a look at some of these sentences. When you take a look, at the very top, they mention what I just said a second ago. So let's look at the second paragraph. Notice the second paragraph says, enable deduplication and compression on a vSAN cluster to eliminate duplicate data and reduce the amount of space required to store data. On the vSphere client, you can very easily see how much space you're saving because of dedupe and compression. And if you take a look, maybe you have a cluster and currently you're using, let's say, two-way mirrors, let's say FTT1, let's say maybe three-way mirrors. Maybe you haven't considered using RAID 5 or RAID 6. Remember, RAID 5 can save you a lot of space compared to a two-way mirror. 33% of the space to be more precise. And RAID 6 can save you 50% of the space when compared to a three-way mirror. RAID 5 can sustain one loss. RAID 6 can sustain 2. Now, if you take a look, after that we mentioned then once again, another thing that you may want to consider is perhaps enabling trim and map. And if you haven't read the release notes or you haven't played with the RVC, maybe you don't know the fact that you could actually do that. And you do it with one command. With trim and map, once you connect to the RVC, you run one command. And after running the command, you have to power off and power on the VMs. Now, let's talk about dedupe and compression only. Remember, this is the feature that was introduced in vSAN 6.2. When you first build a cluster, you have the choice at that point to perform a DFC. And when you do the DFC, disk format version or conversion, the idea is you are doing this operation when A, enabling duplication and compression, or B, enabling encryption. Now here, in this class, we talk about encryption. And we've mentioned in that chapter as well, that once again, when you enable either dedupe and compression or encryption, although you're talking about a couple of clicks, this operation could take a while. Why? Because again, your disk scripts will have to be reformatted so that the disks can support, in this case, the duplication and compression. So notice, at the very top, we mentioned why you may want to consider enabling dedupe and compression. Once again, we're talking about saving space. Number two, if you take a look, it says environments with highly redundant data, such as full clone virtual desktops and homogeneous server operating systems, can definitely benefit from this feature. Now, obviously, this is not going to help you or save you. If you have, let's say, 3 virtual machines, one, let's say, running Linux with a web server like Apache, another one running, let's say, I don't know, a different flavor of Linux perhaps with a database like Oracle, and a third one, let's say, running Windows with Exchange. However, if all of your OSs, or the majority of them, are, let's say, the same type, let's say, for argument's sake, Windows 2016, then you better believe this could save you a lot of space. Now, again, there is a drawback of the duplication and compression. And the drawback is that if you lose a disk in your disk group, that means if any disk, whether cache or capacity, fails, at that point, in order to replace that disk, you have to take apart the entire disk group. That may be why, perhaps, we added compression only. With compression only, you don't have that problem. So remember, if you want to enable the duplication and compression, it's nothing more than one click. But at that point, you may want to take a nice little break, because again, you're going to notice that slowly but surely, every disk group in your environment will be taken apart automatically. The disk groups will be removed. And again, at that point, the disks will be reformatted, and then the disk groups get recreated. So you may want to consider using that feature or enabling that feature on day one when you first build a cluster. But maybe you didn't do that. So maybe again, that's more of a day 2 type of operation. And when you take a look, remember, this feature only works if you have the all-flash architecture. So what I'm going to do here is I am going to switch to the lab. And then at that point, I'm going to show you what happens when you enable the duplication and compression. But before we do that, let's go to this page. Here, we continue talking about the duplication and compression. So here's where they mention the rolling reformat. Remember, it's nothing more than one click. However, it will take a while. In the lab, if you do this task, expect this to take probably 15 minutes, roughly speaking. Now, if you take a look, it says depending on the data store on the vSAN data store. Once again, this process might take a long time. Now, in real life, of course, this could take hours, not just 15 minutes. It really depends on how many disk groups you have, how many disks, and how many hosts. Now, when we look at this page, here, we're talking about, again, dedupe and compression. And if you look at the different statements, let's take a look at a couple of them. Number one, here they tell you when the duplication and compression take place. And notice again, they mention it occurs inline when data is written from the cache tier onto the capacity tier. Number two, they mention that the duplication and compression they use a fixed block size. And again, this is applied within each disk group. And when it comes to compression, the idea is to take 4K blocks and again, compress them into 2K blocks. If you cannot compress into 2K blocks, then we write the data uncompressed. And when you take a look, in this particular page, we talk about the concept of disk management, things to consider. I've mentioned some of these already. So let's take a look at bullet number 1. Once again, if you enable the duplication and compression, you cannot remove a disk from a disk group. Typically, you remove a disk from a disk group if the disk has failed. So here the drawback is that if you lose a disk, once again, whether it is the cache or capacity, you have to take apart the entire disk group. Notice that's what they tell you in bullet number 2. And bullet number 3 says a single disk failure causes the entire disk group to fail, which means, right, that you may really want to consider perhaps having multiple disk groups instead of one per host. It's always a good idea to have multiple disk groups and ideally multiple controllers per host. Here in class, remember, we only have one disk group per host. And if you think about it, we only have one capacity disk per disk group. So here in class, no matter what you do, if you try to remove the disk from the disk group, you're taking apart the disk group. But remember, you would have to take apart the disk group to repair one single drive. Now, when we look at this page, here we talk about design considerations. So let's take a look at this and then we'll do our first demo. Now let's take a look. Here it says, if you use the duplication and compression when it comes to virtual machine storage policies, remember, your VMs are thin provisioned by default. Without the duplication and compression, you have the choice to create a policy where you're reserving 25% of the space, 50% of the space, or 75% of the space. Now, besides that, of course, you could save 100% or reserve 100%. With dedupe and compression, either the VM is thin provision, or again, you're reserving 100%. You cannot use the 25%, 50%, and 75% choices. Notice, number 2, it tells you something I've mentioned several times. This will not work if you have the hybrid architecture. This feature only works if you have the all-flash architecture. And when you take a look at bullet number 3, it says the processes of the duplication and compression incur compute overhead. That means what? You're going to have a little bit of CPU overhead. It may not be significant, but you may notice it. So before perhaps you enable dedupe and compression, you may want to do some benchmarking. Then you enable dedupe and compression, and then you compare the results. Now, when we take a look, the last few bullets, they mention once again, you have advantages and disadvantages. So remember, maybe you care about saving space and you have plenty of CPU resources available. So that may be what matters to you. For other people, that may not be the case. So that is something to consider. And if you take a look, before we talk about compression only, let's switch to the lab. Let's enable the duplication and compression. And let's wait 1 minute to take a look at what happens if you look at the recent tasks. All right, so let's switch and go to the lab. I'll see you there. Welcome back. Now, let's play with the vSphere client. Let's use some commands and let's take a look on how to enable the duplication and compression. So, what I'm going to do for this demo is I am going to take my second cluster. Now, in the lab, you're going to be playing mostly with the first cluster. But in my demo, I'm going to use the second one. So let's take a look at SB vSAN 01. If I go to the Configure tab, here you can see that when we look at the different services, as we call them, when it comes to space efficiency, here you see none. Now, what I'm going to do is I'm going to click on Edit. Now, when I click on Edit, you're going to notice in 7.0 Update 1 that at the very top, you have 3 choices now instead of 2. None, compression only, which is new in 7.0 Update 1, and deduplication and compression. Prior to 7.0 Update 1, you only have none or dedupe and compression. So right now, what I'm going to do is I'm going to show you that if I connect to one of the servers in the second cluster, not the first, but the second, what I'm going to do in this case is I'm going to show you how big the data store is right now. Now, I've made some changes here. Yours should be 200 gigs. Mine, however, currently is not. Notice mine is 150 gigs. So remember, yours will be 200. Mine will be 150. Now, let's take a look at this environment. So what I'm going to do here is I am going to choose deduplication and compression. Remember, this requires a rolling reformat. That is not the case with compression only. So I am going to click on Apply. Now, if you take a look, I had a couple of other choices, but in this case, I want to show you that the system now is going through changes. The cluster is going through changes. And you're going to see different tasks taking place. Now, what I'm going to do is I'm also going to show you that if I go to the command line, the idea here is if I type ESXCLI vSAN debug, here I'm going to see a series of commands. Now, among these commands, you have a few commands related to your disks. Let's take a look at one of them. Now, what I'm going to do here is I'm going to type ESXCLI vSAN debug disk list. Now, this command will show me every disk that I'm using for my vSAN cluster. And what it's going to do is it's going to show me what the disks support. For example, encryption, deduplication and compression, or just nowadays compression only. So remember, this will take a while. So if you take a look, I'm just going to pick one disk randomly. Remember, this drive, target 1, in class, is my cache device. So if you take a look, here you can see that I'm looking at controller 0, target 1, lone 0. It belongs to SB-ESXi03. You can see the disk format version. You can see this belongs to a particular disk group. Remember, we only have one disk group here in class. You can see this is a solid state drive. It is my cache disk. And it is actually in your inventory. Remember, CMMDS is one of the many processes that controls vSAN. CMMDS, to be more precise, is the one that actually keeps track of your inventory. Now, if you take a look, here you can see that I have not enabled encryption. And if you take a look, remember, this will take a while. So this eventually will change. So I wanted to show you that. And if we go back, of course, to the GUI, you can see right here in class, because my data store is smaller, the system shows you that I have chosen to enable deduplication and compression. So I wanted to show you that. So now we're going to cut back and we're going to go back to the actual lecture.